Hello guys, and welcome back to my YouTube channel or the VIG Structure Hub. This is the #1 channel for structural insight and a place where you learn, build, and innovate. So if you have not subscribed to the channel, please subscribe and hit that notification bell so that you may be the first person to be notified when I upload a video. And today I want to talk about influence line. So what is an influence line? So influence line is a graphical representation that shows how a specific response, such as reaction, shear force, or bending moment at a particular point in structure varies as a unit load moves across the structure. So an influence line is a graphical representation that shows how a specific response such as reaction, we have shear force, or a bending moment at a particular point in a structure varies as unit load moves across the structure. So that is the definition of influence line. Is a graphical representation that shows how a specific response, that is reaction, shear force, or bending moment at a particular point in a structure varies as the unit load moves across the structure. So tells how much effect moving load like vehicle on a bridge will have on a particular point in a structure. So tells how much effect a moving load like a vehicle on a bridge will have on a particular point in the structure. So this method was invented by E. Winkler. It was invented by E. Winkler. This is the inventor. And it was invented in 1867. And what is a unit load? A unit load A unit load is a hypothetical load is a hypothetical load a hypothetical load of 1 unit magnitude. Is a hypothetical load of 1 unit load. A unit load is a hypothetical load of 1 unit magnitude, usually 1 kilonewton. So under influence line, I'm going to discuss about the followings. Number 1, influence line for reaction. And under this, I will discuss number 1 or A, simply supported beam. A simply supported beam is a beam resting on 2 supports only. And then B, beams overhanging on one ends. Beams overhanging on one end. Then C, we have overhanging on both ends. On both ends. Then no, there is no D. Then number 2, I will talk about influence line for shear force. Influence line for shear force. And then the last one, this is V. Number 3, influence line for the moment. Like that. So without wasting time, I want to begin with number 1, and this is influence line for reaction. So number 1, we have influence line for reaction, and we will begin by a simply supported beams. So what is a simply supported beams? This is a beam resting on 2 supports. So beam resting on 2 supports, and such a beam can be analyzed. Using the 3 equation of equilibrium. And I hope you know the 3 equation of equilibrium, which says that summation of vertical forces is equal to 0. Summation of horizontal forces is equal to 0. Summation of moment about a point is equal to 0. So for example, if you have a beam like this is a simply supported beam, and this is A, this is B, this is RA, and this is RB. So such a beam has a length L, like that. So for you to analyze this beam and determine its reaction using influence line, you will consider a 1 unit load from support A. So consider a 1 unit load from support A. So we assume our unit load is at this point. So this is 1 kilonewton, like that. So this distance from the support A to where the unit load is acting, we call it X, like that. So we have considered our unit load from support A, which is here. Let's call it point C. This is 1 kilonewton acting at point C at a distance of X from A. So this is a simply supported beam. So to calculate for reaction A and reaction B, we will say, because such a beam can be analyzed using the three equations of equilibrium, we will say summation of moment at a point is equal to 0. So let our point be A. So it means summation of moment at RA is equal to 0. So when we are summing some moments at point A, we are summing moment at point A to get reaction B. So this is to get reaction B. So let's now consider RB, because we want to get this RB. So summation of moment at RA is equal to 0. So RB is moving in anti-clockwise direction in reference to RA or point A. So you will say, because a moment is equal to force times perpendicular distance and the reaction B is a force, so you will say minus RB, because it is moving in anti-clockwise direction, times L. Then you close the bracket, and then we will come to this 1 unit load, in which direction is moving in reference to point A. It is moving this way. This is clockwise. This is clockwise. So clockwise is plus 1 times X, because the distance is X, and then is equal to 0, like that. So we will have minus LRB plus X. 1 times X is X, is equal to 0. Then X is equal to L. This one will cross to the other side, is equal to L RB. So X is equal to L RB. But since we want RB, we divide both sides by L by L. So L here, it cancels with that. So RB is equal to X all over L. So this is RB. So what about RA? So to get RA, you will say summation of vertical or downward forces is equal to summation of upward forces. So the downward forces is 1 kilonewton, and the upward forces is RA plus RB. So we have RB. We can substitute RB with X over L. So you will say 1 is equal to RA plus X over L. So in other words, it is RA plus X over L is equal to 1. I have just interchanged this. So to get RA is equal to 1 minus, this one will cross to the other side, so it will change sign, which is positive to negative, minus x over L. So this is RA and this is RB. So this is how you obtain RB and RA reaction for a simply supported beam. So you will see more or you will understand more when we will be tackling examples. So that is all about simply supported beam. We now proceed to number 2, which is a beam overhanging on one side. So B, we have beams overhanging on one side. Remember, this is reaction. So consider a beam shown below. So this is beam, overhanging beam on this side. This is support A, support B. Then you have reaction A, reaction B. So the overhanging portion is distance A, is at distance A. So for us to calculate reaction at A and reaction at B, we will consider a 1 unit load from support A. So let's consider this unit load at this point. So this is 1 kilonewton. Then the distance from here to here is x, like that. So for us to calculate reaction A and reaction B, you will say summation of moment at A is equal to 0. In other words, use the 3 equations of equilibrium to calculate reaction A and reaction B. So we can consider any point. So let's consider, okay, we have already considered point A by saying summation of moment at A is equal to 0. So this one will help us to get reaction B. Now, in which direction is reaction B moving in reference to point A? It is moving in anti-clockwise direction. So it is minus RB times distance, which is L, like that. And then we will come to 1 unit load here. In which direction is this 1 unit load moving in reference to point A? It is moving in clockwise direction. So plus 1, then time the distance from here to here is x minus A. And then is equal to 0. Let's open the bracket. This is minus L RB plus, let's open this bracket first. So we have 1 times x, which is x, 1 times minus A, which is minus A, which is equal to 0. You can also open this bracket, minus L RB plus x minus A is equal to 0. So this can cross to the other side such that you can have x minus A is equal to L RB. But since we want RB, we will divide both sides by L, So here, then RB, which imply RB is equal to x minus A over L. And then we will come to RA. So for us to get RA, you will consider this equation of equilibrium. Summation of vertical forces is equal to summation of downward forces. So the upward forces is reaction A plus reaction B, and the downward forces is 1 kilonewton, like that. So already you have RB. So you'll say RA plus x minus A over L is equal to 1. So RA is equal to 1. This one will cross to the other side, so it will change from positive to negative, minus into bracket x minus A all over L. So this one will be 1 minus x minus A over L. So the LCM is L over 1. So 1 will go into L times 1 will be L. L minus L into L is 1. Then 1 times x, this one will be x minus A. So this one is equal to L minus x plus A over L. So this is RA, like that. So that is RA. So we have the last one for reaction. This is overhanging both ends. Remember, this is for reaction. So consider the beam shown below. So this is at A, this is B, this is RA, this is RB, and this is distance L. This is overhanging portion on the left side, overhanging portion on the right side. So this overhanging portion is B, is at distance B, and this one at distance A. So for us to determine the reaction at RA and at RB, we will first consider a 1 unit load at any point from support A. So let's consider at that point. So this is 1 kilonewton, and this is at point, it is at point C. And then this distance is x. This is distance x from the left overhanging side to where we have considered a 1 unit load of 1 kilonewton. So we will sum moment about a point. So summation of moment at a point is equal to 0. So let's say RA, summation of moment at RA is equal to 0. You can sum even at RB. So it will just give you the same answers. So summation of moment at RA is equal to 0. This is to help us get RB. Sorry. So in which direction is RB moving in reference to RA? It is moving in anti-clockwise direction, like that. So you will say minus RB times distance from RA to RB is L. This is L. After that, we will come now to a 1 unit load, which is 1 kilonewton. In which direction is this 1 unit load moving in reference to point A? This is clockwise direction. So plus 1 times distance. Distance from RA to where this load is acting is x minus A, like that, then is equal to 0. So minus minus L RB plus, let's open this bracket. So we will have x minus A is equal to 0. After that, this will cross to the other side. So it will change from negative to positive. So we'll have L RB is equal to x minus A. So to get RB, divide both sides by L, like that. So RB is equal to x minus A, x minus A all over L. So this is RB. Now RA, to get RA, you will say summation of vertical forces is equal to summation of downward forces. So upward forces is RA plus RB, which is equal to downward forces is 1 kilonewton. This is 1. So we already have this RB as x minus A over L. So we substitute RA plus x minus A over L is equal to 1. Now, because we want RA, you will say RA is equal to 1 minus x minus A over L, like that. So this one will be is equal to 1 over 1 minus so 1 over 1 minus x minus A over L. So the LCM is L. 1 into L is L. L times 1 is L. Minus L into L is 1. Times this, it will be x minus A. So this one is equal to L minus x plus A all over L. So RA is equal to L over L minus x plus A over L. So this one is equal to 1 minus x plus A over L. So this is RA. So example number 1, sketch the influence line diagram for the reaction at A and the reaction at B for the beam shown below. So this is the beam. So solution. First, consider a 1 unit load at any point from support A. So let's consider a 1 unit load at this point. So this is 1 kilonewton and it is at distance x from A. Now, to get reaction A and reaction B, we will say summation. You will use this equation, summation of moment at RA is equal to 0. Then this one will help you to get RB. So this is RB. To get RB. Now, in which direction is RB moving in difference to RA? It is moving in anti-clockwise direction. So this is minus 10. All anti-clockwise forces are considered as negative. And clockwise positive and clockwise forces are considered as positive. So minus 10 times distance, yes, this is minus 10 times RB, like that. Or you can say, for a simple understanding, you can say because RB is moving in anti-clockwise direction, you'll say minus RB times distance, which is 10. Then you close the bracket, and then you come to 1 kilonewton, in which direction is moving in difference to RA. It is moving in clockwise direction. Then you'll say plus 1, and then the distance, perpendicular distance. The perpendicular distance is x times x is equal to 0. So minus 10 RB plus x is equal to 0. Then you will say this will cross to the other side, so it will be x is equal to 10 RB. Divide both sides by 10 by 10. So which imply RB is equal to 0.1x. 0. Because this, it will count with this. So 1 over 10 is 0.1x. So this is RB. To get RA, you will say summation of vertical forces is equal to summation of downward forces. So the upward forces is RA plus RB, and the downward forces is 1 unit load. So RA is unknown plus RB is known. 0.1x is equal to 1. So RA is equal to 1 minus 0.1x, because it will cross to the other side. And then after this, we will come and draw a table for coordinate. So table for ordinate, like that. So table for ordinate, we will have x, and then reaction A, and then reaction B, like that. Because this is a 10-meter span, you will have a coordinate for which is equal to a total length of 10 meters. So you will distribute x until the total gives you 10 meters. For example, you can use a span of 2, 2, 2, 2. So you'll have 2, then another 2. You start from 0. And then 2 plus 2, 4, then 6, then 8, then 10, like that. And then you'll come to RA. So what you will do to get RA, you will replace in this formula where we have x, you replace with a value which is lying on this x, on the x side. So for example, if we want to get for 0, you will take 1 minus 0.1 times 0, which will give you 1. So this one will give you 1. And then let me use the calculator. And then you will come to 2. So for 2, you will take 1 minus 0.1 times 2. Then you get the answer. So 1 minus 0.1 times 2. So you'll get 0.8. Then you come to this one, so you'll replace here with 4. So this is 0.6. Come here, replace with 6. This is 0.4. Then come here, replace with 8. 0.2. Then replace with 10. You will get 1. Yes. And because RA plus RB is equal to 1, it is here. So to get RB, just take 1 minus 1. It will give you 0. Yes. Make this the subject of the formula. So RB is equal to 1 minus RA. Like that. So when you come to this one, take 1 minus 0.8. It gives you 0.2. Come to here. Take 1 minus 0.6. 0.4. Come here. 0.4. 1 minus 0.4. 0.6. This is 0.8. And this is 0. Like that. So let's now draw the influence line for this beam. So this is how we draw the influence line. So this is the beam. You'll extend this line and also this one. So this is RB and this is RA. And then you'll draw the baseline. This is the baseline for reaction, for influence line for reaction A. So above the baseline is positive, below is negative. Again, influence line for RB. Above is positive, below is negative. And then this is our coordinates. So as you can see, again, remember to note this, the length, which is 10 meters. So we'll start from this side. So at 10 meters, we have 0. So it means at this point is 0. So this one done. And then at 0 ordinate is 1. So this is the 0 ordinate. So 1. And then you will join this like that. So this one done. So remember to start with the main ordinates. So the main for this beam is at 0 distance and then at 10 meter distance. And then you'll finish with the remaining ordinate. So at 8 meter distance, we have 0.2. So Yashom is here, 0.2. So this one done. Then at 6, we have 0.4. This one is done. And then at 4, we have 0.6. This one is done. And then at 2, we have 0.8. This one is done. So no negative reaction for this beam. So all are positive. We proceed to reaction B. So for reaction B, we'll start from this side, which is this side. So we approximate from this baseline to where 1.0 is. So we assume is at this point. So this is 1.0. So this is for the main. And then at 0 ordinate is also 0. So here is 0, 0. Then we join the two like that. So let's now finish the remaining ordinates. We have 0.8 in line with this. So this is 0.8, 0.6, 0.4, 0.2. Done, done, done. So that is how you draw the shelf, the reaction, the influence line diagram for the reaction for the beam shown. So that marks the end of this question. We proceed to example 2. So example number 2, sketch the influence line diagram for the reaction at A and the reaction at B for the beam shown below. So this is the beam. It is overhanging on the left side of support A. So solution. So the first thing to do is to consider a 1 unit load from support A, let's say at this point. So this is 1 kilonewton. And then the distance will be x. So this is distance x from the overhanging side to where 1 kilonewton is. And then to get area A, this is area A, and this is area B. This is C, point C. So to get area A and area B, some moment at any point. So summation of moment at area A is equal to 0. So this one will help you to get RB. So in which direction is area B moving in reference to area A? So it is moving in anti-clockwise. See the movement of my hand. Anti-clockwise direction. So this is minus area B times distance from here to here is 12. Minus area B times 12. And then we come to 1 kilonewton unit load. So in which direction is moving in clockwise direction? Plus 1 times distance from support A to C. So this is x minus 2. X minus 2. So this one is equal to 0. Minus 12 area B. You can now open the bracket. Minus 12 area B plus, this is x minus 2 is equal to 0. So this will cross to the other side. So it will change from negative to positive. So we will have 12 area B is equal to x minus 2. To get area B, divide both sides by 12 by 12. So area B is equal to x over 12 minus 2 over 12. So this one is equal to 1 divided by 12 . So let's remain like that. So this is area B. Then area A, you will obtain area A by considering this equation of equilibrium, summation of upward forces is equal to summation of downward forces. So the upward forces is Ra plus Rb, and the downward forces is 1 kilonewton. So Rb is here. You can substitute. So Ra plus x over 12 minus 2 over 12. So 2 divided by 12 is 1 over 6 is equal to 1. So if this will cross to the other side, it will change sign from this positive to negative. So this one will be negative. So Ra is equal to 1 minus x over 12 minus 1 over 6. The whole of this is crossing to the other side. So this one is equal to 1 minus x over 12 plus 1 over 6 when we open the bracket. So 1 plus 1 over 6, 1 plus 1 over 6, it will be 7 over 6. So minus x over 12 minus x over 12 plus 7 over 6, and this is Ra. So this is Ra. Now we can now determine the coordinates for this reaction A and reaction B. So we have X and we have Ra and we have Rb. So the distance is 2 plus 12. So this is 14. So 14, we can have a span of 2, 2, 2, 2. So 2 times 14 is 7. So here you'll have 2. Now you start from 0. So this is 0, 2, 4, 6, 8, 10, 12, 14, like that. And then we'll come to Ra. So as you can see, Ra is equal to minus x over 12 plus 7 over 6. So we will be substituting x with these values 0, 2, 4, 6, 8, 10, 12, 14. So we will start by 0. So this is 0. So it means minus 0 over 12 is 0. So here we'll have 7 over 6. So 7 over 6 in decimal places. This is 1.17. 1.17. We'll come to 2. So you'll replace here with 2. So this is negative 2 over 12 plus 7 over 6. So this is 1. Come to 4. Put here 4. .83. Come to 6. Here 6. Zero 0.67. Come to 8. Here 8. Zero 0.5. Then you come to 10. 0.33. Then you come to 12. 0.017. Then the last one 14. This is 0. So to get RB, take RB is here. To get RB, you'll take 1 minus RA. As simple as that. So for 0, you'll take 1 minus 0.17. No, for 0, you'll take 1 minus 1.17. So this is negative 0.17. Again, you'll come here. 1 minus 1 is 0. You'll come here. 1 minus 0.83. This is 0.17. Then 0.67. This is 0.3. You'll come here 0.5. Here it will be 0.67. Here it will be 0.83, like that. And then 1 minus 0, this is negative 1. So let's now draw the diagram. No, this is 1, not negative, because it is 1 minus 0. 1 minus 0 is equal to 1, like that. So let's now draw the influence line diagram. So the influence line diagram, I will draw it here. Or let me draw it here. Yes, let me draw it here. So this is the influence line diagram. So let's now draw the influence line diagram for this beam. So you will extend this line like that. Also extend this one like that. And then you will come and draw the line, the baseline here. So here will be influence line for RA, then influence line for RB. So if we start from RA, you have 0. This is 0. And remember, this is 10 meters. So, and at this point, also extend this one. Let's extend this one. So here is 1.17. So let's say it's here. 1.17. So you will join these dots like that. And then you will come to 0.17. Let's say it's here. 0.17. Done. 0.33. 0.33. Done. 0.5. Done. 0.67. 0.67. Done. 0.83. 0.83. 0.83. And then we have a 1. So here is 1. Like that. And then you come to the RB. Again, you'll draw the baseline. The baseline for RB. So RB, here is 1. So from here, you assume 1 is here. So this is 1. So above this baseline is positive and below is negative. So here is 1. Like that. So done. And then here is negative 0.17. So negative is around there. So negative 0.17. And then you'll join these two. And then here is 0. At 2 meters is 0. So here is 0. So it must come through this like that. Like that. So here, is 0. So here done. Here done. Then we come to 0.17. So 0.17 done. 0.83. 0.83 done. No, 0.33. 0.33 done. 0.5. 0.5 done. 0.67. 0.67 done. And then 0.83 done. So that is how you draw an influence line for this beam. We proceed to example number 3. So example number 3, and this is the last example for reactions. Sketch the influence line diagram for the reaction at A and reaction at B for the beam shown below. So this is the beam. It is overhanging on both sides. It is overhanging 2 meters from support A on the left and 4 meters from support B on the right. So solution. So the first thing to do is to consider a 1 unit load from the left support, which is A. So this is 1 kilonewton, and the distance will be x from the overhanging side. So this is distance x. Then to get reaction A and reaction B, we will use summation of moment about a point, or use the 3 equation of equilibrium. So we start with the moment. So summation of moment at A or RA. So this is RA and this is RB. At RA is equal to 0. This one will help you to get RB like that. So in which direction is RB moving in reference to point A? It is moving in anti-clockwise direction. So this is minus RB times the distance. From RA to RB is 20. As you can see, it is 20. So times 20. Then you come to 1 unit load. In which direction is this 1 unit load moving? In reference to RA. This is clockwise, plus 1 times the distance is x minus 2. From here to here is this distance x minus 2. You will get from here to here. So like that. So it's equal to 0. Let's open the bracket. Minus 20 RB plus x minus 2 is equal to 0. So this one will cross to this side. So it will change from negative to positive. So it will be 20 RB is equal to x minus 2. Divide both sides by 20 by 20. Therefore, RB is equal to x over 20 minus 1 over 10. So this is RB, or you can simplify. So 1 over 20, 1 divided by 20. So this is 0.05 x minus 0.1. So this is RB. This is RB. Summation of vertical forces is equal to summation of upward forces is equal to summation of downward forces. So the upward forces is RA plus RB, which is equal to the downward forces. We have only 1 kilonewton in the downward direction, so equals to 1. And we have this one as 0.05x minus 0.1. Therefore, we can substitute RA plus 0.05x minus 0.1 is equal to 1. Therefore, RA, the whole of this will cross to the other side and it will change sign from positive to negative. Therefore, RA is equal to 1 minus 0.05 minus 0.1, like that. So RA is equal to, this is 1, open the bracket, minus 0.05x plus 0.1. So RA is 1 plus 0.1 is 1.1 minus 0.05x. So this is RA. Let's now draw the table. Ordinate table. Ordinate table. So you have x, RA, and then you have RB. So we have 2 plus 20, which is 22, plus 4 is 26. So we'll use a span of 2, 2, 2, 2. So this is 0. We start with 0. This is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Let's extend the table. So you have 22. Then 24, 26. So we have 24, then 26. So this is X, this is RA, this is RB. X should be here, like that. Yes. So to get RA, if you replace from this equation, replace this equation which says RA is equal to 1.1 minus 0.05 x. So you replace this x with 0, so times 0. So it will remain 1.1. So here it will be 1.1. And then you come to 2. So this is 2. So 1.1 minus 0.05 times 2. So here is 1. Then replace 2 with 4. (0.9). Replace 4 with 6. 0.8. Replace this with 8. 0.7 with 10. Replace with 10. 0.6. As you can see, it is reducing by 0.1. So here it will be 0.5, 0.4, 0.3, 0.2, 0.1, 0. Negative 0.1, negative 0.2. And then for RB, because RA plus RB is equal to 1, so RB, it will be 1 minus RA. So 1 minus 1.1, 1 minus 1.1, this is negative 0.1. And then 1 minus 1, this is 0. 1 minus 0.9, 0.1, sorry, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. And then 1 minus 0, this is 1. And then 1 minus 0.01, 1 minus 0.01, 01, not 01, 01 is 1.1. 1.2. And you are done with the table. What follows next is now to draw the influence line diagram. Let's now draw the influence line diagram for the reaction at A and reaction at B for the beam shown below. So these are the baseline for influence line for reaction A and the baseline for influence line for reaction B. So above this baseline is positive, below is negative. The same to this, above positive, below negative. So we start with reaction A. We will go with the main point. The main point is here at 0. At 0 is 1.1, so 1.1. And then we'll come to at 2 meters. At 2 meters is 1. So here, slightly lower than that. Here is 1. So done. And then we'll come at 20. So 2 plus 20 is 22. So at 22 is 0. So here is 0. And then another one is at 26. 2 plus 20, that is 22, plus 4, 26. So at 26 is negative 0.2. So we assume it is at this point negative 0.2. So 0.2, it is below this baseline. Now we'll join all these to all these points like that. So this is negative 0.2. And then here is 1. Like that. So this one done, 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 done. Let's come to 24. 24 is 0.1. So negative 0.1 around here. So this is negative 0.1. So this one done. 22 done. 20 is 0.1. 20 around here. 0.1. This one is done. Done. This one is done. And then you come to 18. 18 is somewhere here. And 18 is 0.2. Done. 16 0.3. 0.3. Done. 14 0.4. 14 0.4. Done. 12 0.5. 0.5. Done. 10 0.6. 0.6. Done. 0.7. Done. 0.8. 0.8. Done. 0.9. 0.9. Done. And then of course 1 is done. And then of course 0 done. And then we proceed to the other one, which is RB. So let's draw for the main one. So for RB, the last one is 1.2. So the last which is at 26 is 1.2. So we are shown is at this point 1.2 here. 1.2, and this is influence line for RB. So this one done. We'll come to 22. 22 is 1. 22 is 1. Somewhere like there, 1. So 22 done. And then we'll come to 2. 2 is 0 here. This is 0. So 2 done. And then RB is negative 0.1. So here is negative below the baseline. Negative 0.1. Negative 0.1. So here. So let's join these two. So let's one be here. Like that. So we can as well include the remaining part. So let's go to 4. No, let's start with the second last, which is at 24. This is 1.1. So 1.1. This one done. We come to 20. 20 at that point. So this is 20. No, 0.9. 0.9 done. Then 0.8. 0.8. This one done. 0.7. 0.7 done. 0.6. 0.6 done. 0.5. 0.5 done. 0.4 done. 0.3. 0.2. Done. Then 0.1. Done. So that is how you draw influence line for this beam. And this marks the end of this question. So today we have learned about the influence line and how to draw the influence line for reaction. Number 1, simply supported beam. Number 2, we have an overhanging beam on one side, and number 3, overhanging beam on both sides. And then we have tackled each examples for each case. Now tomorrow I will talk about shear forces, and then we will later talk about the moment, and then we'll be able to tackle more examples from past papers. So thank you for your time, and we meet again in my next session.